Hi, this is King of Review. Here we have to find the maximum and minimum values of integers that satisfy this inequality over here on the right. Now right away, I notice that there's two different bases in my logs in this inequality. One has base 10, one has base x. I would like to make them both have a base of 10 since that seems a lot easier than a base I don't know. And I can do that by using what's called the change of base formula. If I have a log base b of a, and I'd rather have logs with a base of some number c, I can write this as the log base c of a over the log base c of b. So in this inequality I have the log of x, and I'd like to change this second log so it also has a log base 10, just like the first log. Using the formula, this becomes the log of 10 over the log of x, and that's less than 5/2. Now, I know that 10 to the first power is equal to 10, which means the log base 10 of 10 is 1. Now, I'd like to get log of x out of the denominator. In fact, I'd like to get rid of all the fractions in this problem, so I'm going to multiply through by 2 times the log of x, so that the two denominators will cancel out. 2 times the log of x times log of x is 2 times log of x squared. The logs canceled out in the second term, but I still have to multiply by 2. And the 2's canceled out in the final term, but I still have to multiply by the log of x. Now, I'd like to substitute something for the log of x, since I have the log of x squared and the log of x by itself. To simplify this equation, let's try introducing a variable y and setting it equal to log of x. Substituting that into the equation, I get 2y squared plus 2 is less than 5y, and if I move 5y to the left side, so that 0 is on the right, I get this inequality, which is much easier to solve. I can factor it fairly simply. 2y times y is y squared, and by working a few numbers around, I can figure out that -2 and -1 multiply to give me +2, and if you distribute them, they'll add up to give me -5y. If this product is less than 0, if this product is negative, that means one of two things is happening. Either the first one is negative and the second one is positive, or the other way around, the first factor is positive and the second one is negative. If I solve these equations, I get y is less than 1/2 and y is greater than 2. Wait a second. You can't have a number that's smaller than 1/2 and also bigger than 2 at the same time, so this solution does not work. On the other side, I have y is greater than 1/2 and y is less than 2. If we look at that on a number line, we can easily see that that does work. We need y to be somewhere in between 1/2 and 2. So 1/2 is less than y, which is less than 2. Let's plug in what y equals. This is 1/2 is less than the log of x, which is less than 2. And if I want to get rid of the log so that I get x by itself, I need one more property of logs that says if we raise a number b to the power log base b of x, the b and log b cancel and I'm just left with x. In particular, since the base of this log is 10, if I raise 10 to the power of all three parts of my inequality, 10 to the 1/2 is the square root of 10, 10 to the log base 10 of x cancels and I get x, and 10 squared is 100. So there's the whole range of solutions for x, but remember, I'm only looking for integers. The square root of 10 is somewhere in between 3 and 4. It's 3 point something something something. So if I think about all the integers in this range, the lowest integer that's actually in this range is 4, since the lowest number is a little above 3, and the highest number can't be 100, it has to be less than 100, so the highest integer in this range is 99. Since the interval in integers goes from 4 to 99, and I want to know the sum of those two numbers, the minimum and the maximum, I want 4 plus 99, which equals 103. So there's my answer. Thanks for watching.